The second algorithm is basically the k nearest neighborhood algorithm. It is a non-parametric algorithm, and this is the code which I have displayed, and it is actually the working code which I've implemented in Google Colab. Over here, I'm defining my two empty arrays, that is the model scores and the indexes using numpy array. And then by changing the value of different k, I'm evaluating the performance of my classifier. So I'm varying my value of k from 1 to 30, and I'm storing the obtained accuracy in model underscore, and correspondingly I'm also storing the value of x in this empty array of indexes. So after iterating for 30 iterations uh, over here, uh, I'll be obtaining two arrays which will be storing model scores and indexes. So over here, if you see, this is actually the my pipeline based architecture, which has processes, standard scalar processes, and the model which I'm using, which is k nearest and neighbor. The hyperparameter which I'm using is the nearest neighbors, that is n neighbors, and x is the value which is being varied from 1 to 30. So the other hyperparameter is basically the type of distance which we can use, and the possible options are Euclidean distance and the Manhattan distance. But after using those parameters, I have not been able to see any significant change in the performance. So using the k nearest neighborhood, I have been able to obtain the accuracy of 0.87, and this is the F1 score, uh, and this display is actually showing the F1 score for each and every class, and this is the confusion matrix obtained for 10 different classes, which are basically the numbers. Due to short of time, I shall be going and explaining things in a brief way. And this is the plot which I've obtained for various values of k. When k is equal to 9, I have obtained the accuracy of, and that is the best accuracy with the k nearest neighborhood algorithm. Next is the decision trees, in which the again the pipeline architecture over here the pipeline based architecture, and over here the hyperparameter is the maximum depth, and I'm changing value of x from 1 to 20. I'm doing the process for 20 iterations, and again storing the classification accuracy, that is the model accuracy, in an empty array over here, and corresponding values of axis x in indexes. So I'm looking for the maximum value, that is maximum accuracy, and correspondingly finding out the best value of x, which is showing the depth of the decision tree. So again, this is the report giving me the accuracy of 0.74, which is not that good, and the confusion matrix. Moving on further, this is the plot which I've obtained when my decision trees are, that is the depth is 10. There's no point of going further because that will make my model further complex. Support vector machine, in which I'm using three various kernels, and I'm iterating my whole process for three iterations, in which I'm evaluating the performance of the optimized model through SVM for three different kernels. Rest of the processes are almost identical, just like I have mentioned in my previous slides. And then storing the classification, that is the model accuracy, the scores in this empty array, and correspondingly indexes. And this is the report which I've obtained, and the accuracy is 0.95, which is the F1 score. The overall F1 score is 0.95. Moving on further, this actually is showing it's a display which shows the classification accuracy obtained with different kernels. RBF gave me the best classification accuracy used through SVM, and a linear kernel is also approaching the almost using linear kernel, the performances of RBF and linear kernels are almost are identical. So this is about SVM. Then the logistic regression, again the similar processes, in which a pipeline based model then predicting the model on the X test, and then generating the classification report along with the confusion matrix. In the random forest, in which I have done the variations on two different hyperparameters, which are the depth, that is the maximum depth of my random forest, and the the number of random forests which I am using. These are two different for loops which are actually evaluating the performance of the random forest for different depths, for different depth of the random forest and number of this. So over here the value of x is being varied from 1 to 20, and over here the value of x being varied from again 1 to 20. So after obtaining the best hyperparameters, I've been able to obtain the accuracy of 0.90, that is the F1 score, overall F1 score through random forest, and this is the random forest through random forest, and the best hyperparameter, the confusion matrix. And this is the plot again showing the classification performance when I have varied the depth of my tree and the number of trees which I have used. So I'll stick with the value of 10, that is depth of my random forest, and 15, and that is the total number of trees in random forest algorithm. After thoroughly reviewing and applying 6 machine learning algorithms with the best optimal tuning hyperparameters with pipeline architecture, SEM gave the superior performance in terms of classifying accuracy when RBO-kernel was selected. KNN with case 9 and random forest with the maximum depth of 10. In total 100 trees gave classifying accuracy of 87% and 95% respectively. I have also done some experiments using artificial neural network, but I have done, that is the tuning of the neural network in a crude way, but whatever I have implemented I will show in my next slide. But so far, keeping in view the limitation, that is the time limitation, I'll stick with the 6 algorithms in my conclusion slide, where the best performance, that is the F1 score, is obtained using the SVM. This is the implementation, that is I'm focusing on the core part of the sequential based deep neural network, in which I have initializing my input layer, my hidden layer. Over here the activation function which I have used is the ReLU. Column -1 is basically showing the input layer size, because I have subtracted one column -1, basically actually showing that I have excluded the target column. So over here, the optimizer which is used is the Adam, and loss is categorical cross entropy, and the performance, that is the performance metric, is the accuracy which I've used. And after this is the configuration of my network which I have used so far, and even by doing the crude tuning of my neural network, I have obtained the accuracy of 0.94, which is still very good. And I personally feel that by appropriately changing the hidden layers, doing different settings, DeepNet should give me the best performance as compared to the algorithm which I have implemented and shown in the past slides. And that's all from my side.